All right, high school geometry, part one. We're talking about points, planes, and postulates. A little alliteration there. And everything in between. We'll talk about lines, line segments, rays, and all that other stuff. So we'll start with a point. We all know what a point is, right? So here's a point, right? I put a little point there, right? We call it point A or point B or whatever you want to call it. There's a point. And here's very important about a point. A point has no dimensions. There's no dimensions. Right? We live it in the third dimension, right? Of width, length, and height. And of course, we have a dimension of time. So we live in the third dimension. But a point has no dimensions. Very important. So it's just a point. It's a dot. It's a dot in space. We say, put a point. A point in space. And when we're talking about space, we mean on a plane, which I'll talk about in a minute, right? Not jet planes. So let's get a clear page. All right, let's use red. Start with red. So we have a point, and then we have a line, right? So we have the point, which has no dimensions, right? We'll call it point A, no dimensions. And then we can make a line. We'll make a line, right? So, and when you make a line, you have to have the arrows on both ends because a line has, on both ends, they extend to infinity. To infinity and beyond. That's getting old, right? So they extend to infinity on both ends. That's what a line is. So on a line, and by the way, a line has one dimension. A line has one dimension. So a point has no dimensions, a line has one dimension. And on a line, you can have points, right? You can have, that could be point A. We'll just use A and B, why not? And they could name this line. So and a lot of times you see like they name it line L, something like that. So we can say that line L, right? Line L. Or we can say for this over here, we can also say it could be, we use on top, we make a little line like that, and we say line AB in italics, right? So you can call it line L because it says line L, or you can say line AB because it has 2 points on it. All right. Now, if you see where they don't have the arrows, let's just put a line here. If you see they don't have the arrows, change the color. Let's say you just see 2 endpoints, right? And that's A, B. Well, this is a line segment. It's just 2 endpoints with no arrows, a line segment. And if you have an endpoint and a line going forever, well, this is a ray. That's a ray. Now, in a ray, you can still have points on it. So if we want to name it, right, we can say AB. We can say this is ray AB. Right, and you can write it like this. They'll write the little ray, and you can say ray AB. Right, or you can say this is a line segment AB. So forth. Okay, so we have 1 dimension. We have 2, no dimensions, 1 dimension, and 2 dimensions would be a plane. Right, so let's clear that out. We'll make our plane, and there we go. So a plane, kind of a rough-looking plane. So it's just a shape that's 2-dimensional, right? So this is, you can say 2D is as a plane has 2 dimensions. And a cube, if we made a cube here, well, that's 3 dimensions, right? 3D, 3 dimensions. So on a plane, we can name the plane. That could maybe over here is plane M, right? But then if you see points on the plane, point A, point B, point C, well, there are 3 points on a plane. And so we can name the plane. We can say this is plane M. Or we can say it's plane, naming 3 dots, like ABC, plane ABC. So there's points on a plane. Like we said, the points on the plane have no dimension, and then the plane itself has 2 dimensions, and you can make lines on the plane that are 1 dimension. All right, let's clear that out. Let's make a better looking plane. I'll try to make a better looking plane. All right, a little rough. So if we have lines on our plane, here's a line. We have a line here. Well, we have another line going over here, right? And so we can have our points. We have a point right there. Let's say we have these points. And let's change the color so we can see this better. That's point A, point B, point C. Guess what this one is? Point F. No, just throwing that in there. And let's say that over here was R. So this will be called plane what? Be called plane R, right? Because there's the R. It has no point to it. So if we look at our lines, let's look at a line we have here. Here's a line, right? We can say we have 3 points on this line, right? We have A, B, and C, as you can see over here. That's line A, B, and C. Line A, B, and C. So there's a new term, vocabulary alert. It's called collinear. Collinear points. Now, linear means straight. Linear means straight. And think of co as like your coworker. If you have a coworker, it's someone that you work with. It's someone you're working together with. So collinear is they're on the same straight line. So if you look on the straight line here, line ABC over here, point A, point B, and point C are collinear because they're on the same line. All right, so if I made a line over here, let's say we have a line, and we say this is line A, that's line B, and then we made another line, that's line C, and that's line D. Well, we know that point A and point D are not collinear. Why is that? Well, because they're not on the same line. Simple as that. That's what collinear means. And another term now, next vocabulary alert, is coplanar. Coplanar. What do you think that means? Coplanar means they're on the same plane. So if you look on the plane over here, plane R, A, B, C, and F are coplanar because they're on the same plane. All right, so what points are coplanar? Very easy question, right? You know this, right? Point A, point B, point C, they're on the same plane, so they're coplanar. Now, if we added things to this, let's say I added a straight line, as best as I can make a straight line. Oh, almost missed it. There's a line. And then we say we have another line over here. Really should use a ruler, right? So we can say that there is a line segment here where B and C are on the same line. So B and C are co-what? So B and C, if we make our line segment here, point B, we'll say point B, point B, and point C are coplanar, they're on the same plane, and they're collinear. They're on the same line. But A is not on the line of B, so you can't say point B and point A are collinear. They're not, but they are coplanar. Let's get another picture here. Let's look at these questions here. True or false? Point C, point D, and point E are collinear. What do you think? So let's look at them. Point C, right? There's point C. Here's point C. There's point D. And where's point E? It's over here. Are they collinear? No. No. False. And point F, over here, here's point F. Point B over here. And point C, they're coplanar. Yes. They're on the same plane. They don't have to be connected. They're on the same plane. Now, point F is not collinear with anything. It's not on any line. It's just a point. And here's another question. So let's, well, change the color. If I said here, let's take a line. We'll say, make our line, right? And we'll say that this is line CD. Line CD. So we have line CD here. And what's another name for line CD? DC, right? You could flip it around. That's another line for it. Now, what is the name of this plane? What is the name of this plane? It's called plane M, right? Don't make it plane F, because that's a point. Plane M all by itself, usually in the corner, tells you what plane it is. You can also say this is plane, just put any points. You could say this is plane CDF, right? Because those are the points on the plane, 3 points on a plane. All right, let's move on. Another vocabulary word, the line of intersection. So if we took 2 planes now, like we had a plane here, and we'll use red. So here's a plane, just hanging out. And then we'll use another color. We have another plane coming in like this. And it comes out like that, right? So it's kind of cutting right through it. So the line of intersection is right there where they intersect. That's the line of intersection. That's pretty easy. All right, so we have 2 planes here, plane 1 and plane 2, right? And the line of intersection is L. It's right there. It's where the 2 planes intersect. All right. And now we come to postulates. Let's get a clear page going. And the first postulate, postulate 1, is called the Ruler Postulate. So first of all, what are postulates? Let's put a definition down. Use green, why not? So a postulate is a rule. It's a rule that is accepted, without proof. Without proof. In other words, it's self-evident. Self-evident. It's assumed. Put that down too. It's assumed. Right? So that's a rule. That's a postulate, right? So this is a postulate. And we use the word postulate a lot in geometry. And you can also hear the word axiom. And in other math, you might just hear the word axiom, but in geometry, we use the word postulate. Now, other people debate that postulates are a little stronger than axioms, but that's a debate. So for geometry, just think of postulate, a rule that is, it's accepted, it's just self-evident. Now, a rule that can be proved, what do you think that's called? Because you've done this before. You've probably done it all through middle school and ninth grade. A rule that can be proved is a theorem. And the most famous theorem, you probably know the most famous theorem, Pythagorean theorem. Pythagorean theorem, named after Pythagoras, who lived about 600 BC, roughly around that time. So we know the Pythagorean theorem, a squared plus b squared equals c squared when we want to prove right triangles. So this is a theorem. It's a rule that can be proved. We have to prove it, and we're proving it over and over again. It's been proved. Where postulates are not proved because they're just self-evident. For example, if I say you can draw a straight line from point A to point B, right? So here's point A, let's say, and here's point B. Well, if you use a ruler, you can draw a straight line, right? So that's a postulate. It just seems self-evident. But let's look at postulate 1. So I'll clear that out. We'll give it a couple seconds if you need to write it down. 1, 2, 3, and we'll clear it out. So let's look at postulate 1. So I'll write postulate 1 down. And postulate 1. And in other videos, we'll talk about other postulates, but we'll just do postulate 1 today. So what postulate 1 says, and I'll show you a picture in a minute, it says the points on a line. Points on a line. We know what points are, right? So, we'll just put points on a line. So here's a line, and right here's points, right? We'll call that point A and point B. So the points on a line can be matched 1-to-1 with real numbers. The points on a line can be matched, or measured, right? Can be measured with real numbers. What are real numbers, right? Not fake numbers. Well, in the real number system, we're not talking about imaginary numbers. We're talking about all the numbers that you've been learning since you were probably in kindergarten. Anytime you learn to count all the way through 10th grade, you've learned real numbers. And then finally in Algebra 2, you've learned about imaginary numbers. So just think of any number, right? So like -3 is a real number, 9 is a real number, the square root of 100 is a real number, right? Even the square root of 2 is a real number, right? Even though they're not imaginary numbers, right? The square root of 2 is like pi. They're related. They're irrational. So irrational numbers are real numbers. Imaginary numbers, you get to the point like this. Like, when you do the square root of -2, that's in the imaginary number field. And you would have to look up videos on imaginary numbers. I have them when we get deeper into algebra if you want to look them up. So anyway, the points on a line can be matched or measured with real numbers. That seems so self-evident. Let's look at a picture. So here's a line, right? And say P and Q. So those 2 points, they can be matched together 1 and 1. They can be measured with real numbers, right? So just look on the line here and make sure we have our pen ready. So over here you see 2 inches, and over here you see 7 inches. So if you measure them, obviously 7 minus 2 is 5 inches. And 5 is a real number. And even if you measured, for example, let's say it was 5 1/4, well, that's still a real number, right? So all the numbers you can think of, besides imaginary numbers, those are real numbers. So, and again, it's a postulate because it seems self-evident. Now, also, point P and Q over here will have an absolute value. And you probably first heard absolute value in 6th grade, maybe a long time ago. So absolute value is the distance from 0. For example, if I say the -5, just to refresh you, maybe you forgot, the absolute value of -5 is 5 because it's 5 from 0. Right? What's the absolute value of -12? 12. What's the absolute value of 12? 12. So if we had a number line here, right, here's 0, here's -5. Well, -5 is 5 away from 0, and 5 is 5 away from 0. That's what the absolute value means. So again, with a postulate, it's self-evident. It's accepted without proof. It's used in geometry more than axioms. You'll hear axioms in other math. So and again, the ruler postulate says that any points on a line, P and Q, for example, can be matched. They can be measured with real numbers, and they will have an absolute value. So we know, just also self-evident if you look at this, we know that if P and Q are 5 inches apart, well, O and Q must be further apart, but they could be measured with real numbers also. So that's the ruler postulate, postulate 1. So that was the beginning of geometry. Next video, we'll learn about more postulates.